Hello, in this video we are going to discuss about a project called Smart Street Light, in which we are going to control the light depending upon the light intensity falling on a photoresistor. In order to continue with the project, we have to go to a simulation software called TinkerCAD, and we have to select circuits option and select create new circuit. Upon doing so, we'll get a blank workspace where we can just drag the components from the components list, which is on the right side of the page. And as you can see here, this is the blank workspace and this is the components list. As usual, the main important component is Arduino. So I'm dragging it onto the workspace. And for this project, Smart Street Light, we need a light bulb. So I'm searching for a bulb and dragging it onto the workspace. And we also need a photoresistor to detect the light intensity. We need a power supply, and finally we need an NPN transistor, and it is dragged onto here. The working principle of an LDR is photoconductivity, that is nothing but an optical phenomenon. When the light is absorbed by the material, then the conductivity of the material reduces. When the light falls on the LDR, then the electrons in the valency bond of the material jump to conduction band. But the photons in the incident light must have energy that is superior than the band gap of the material to make the electrons jump from one band to another. Hence, when light having ample energy, more electrons are excited to the conduction band, which grades in a large number of charge carriers. When the effect of this process and the flow of the current starts flowing more, the resistance of the device decreases, hence there would be an increase in voltage. The transistor in which one p-type material is placed between two n-type materials is known as NPN transistor. The NPN transistor amplifies the weak signal enter into the base and produces strong amplified signals at the collector end. These transistors are mainly used in switching applications, also in amplifying circuit applications. So mostly at places where there is a need to sink a current. So let's start with the connections of the photoresistor. Terminal 1 of the resistor should be given to 5 volts here, and we can change the color of the wire to red to indicate that it's a power wire, and the other terminal can be given to one of the analog pins, let's say A5. Let's change the color of the wire to purple to indicate that it's an input wire. Similarly, the same terminal which is connected to A5 should also be connected to the ground. But it is important to attach a resistor to it because resistor helps to prevent the excessive current flowing through the photoresistor so that it won't be burned out. So I'm dragging the resistor, and let's say we should connect this to the ground. So I'm keeping it near the ground and giving the connections there. So these are the LDR connections. Now let's come to the connections of the power supply. So there is positive and negative. The negative of the power supply should be given to the ground as well. So let's keep it here like this, and ground. Here it's connected to the ground, and the positive should be given to the light bulb. So I'm giving the connections to one of the terminal of the light bulb, and let's change the color to let's say red, because the positive terminal is nothing but the power. Now another terminal of the light bulb should be connected to one of the pins of NPN resistor, which is the emitter. So let's give it here, and let's change the color to pink. And this is the collector, and the collector should be connected to the ground of the power supply. So it is given here, and the base should be given to one of the digital inputs of the Arduino. So let's give the connection to, let's say, pin number 3, and we can change the color to some it blue. So these are the basic connections. So these are the revised connections. As you can see, they are a bit little more neater so that the connections would be visible clearly. As you can see, the NPN transistor is connected to the light bulb. This pink wire indicates the connections between both light bulb and NPN transistor. And it is also connected to the negative terminal of power supply, which is also given to the ground of Arduino. And the positive terminal of the power supply is given to light bulb. And also the base of NPN transistor is connected with the resistor just to give the extra resistance so that the transistor won't be damaged. And this other terminal of the resistor is connected to one of the digital pins, pin number 3. Coming to the photoresistor connections, as you can see, this is connected to ground again with a resistor to prevent the excessive current flowing through it. And it is also connected to one of the analog pins, pin number A5. So these are the connections. Now, in order to program our Arduino, we need to provide it a code. And to do that, we need to click on code and go to text option, click continue. So this is the default code we got from the software, which we can just replace with our own code. So this is our code. As you can see, LDR is connected to pin number A5, which is the purple wire. It is given over here. And since LDR outputs some voltage value, we are taking that LDR value, and the light is connected to pin number 3, which is connected through an NPN transistor that is given over here. Now coming to the basic setup, light is considered as output because we are controlling the light based on the light intensity, and the light intensity is considered as an input which the photoresistor inputs to the system. So that is given over here. Now coming to the loop, we take the analog read from the photoresistor, and if the values exceed a certain threshold, that is when there is like a lot of light, the light is set to low. That is how a light bulb should work. So when there's sunlight, the light shouldn't be on, but when there's less light, the bulb should glow. So that is the program. And to check if the program is working or not, let's start the simulation. And as you noticed, the light intensity is less, so the bulb is glowing. Let's increase the light intensity, and the bulb is still glowing because it is not that dark yet. Now I'm increasing the light intensity furthermore, and as you have noticed, the light bulb stopped glowing. So this is this project Smart Street Light, and thank you for watching this video.